At 6:12, on a clear August morning, Avalanche sensors measured 38,000 tons of snow on a bare mountain. Radar showed open rock. The temperature was 18 degrees. But load anchors bent, suspension cables sagged, and the slope tilted under a mass no camera could see. Mount Calder is a national test slope used to validate avalanche models, barriers, and warning thresholds. Summer inspections establish a zero-load baseline. The investigation into the weight of snow began at a bare alpine avalanche slope in summer, with load anchors, radar masts, cable fences, rock gullies, and a concrete control bunker. Every load cell rose together to a winter design value, while radar and cameras showed bare rock. The calculated mass was 38,000 tons. The opening exhibit for the weight of snow pairs the last normal maintenance entry with a pre-incident photograph of the site. Exhibit 1 was checked against a control held outside Highland Avalanche Safety Service, Mount Calder test slope, before it entered the final record. Sophia Marin, the service's structural monitoring engineer, preserved the first local record before any reset or maintenance action. Every load cell rose together to a winter design value, while radar and cameras showed bare rock. The calculated mass was 38,000 tons. In the file for the weight of snow, the account was checked against access control, clock records, and original instrument output. The reference snowpack statement was recorded before shift change and reconciled with badge entries, calls, and handwritten notes. For reference snowpack, the original medium and one independently derived comparison were retained under separate custody. Snow depth radar, load cells, weather stations, and ground deformation sensors estimate slab mass and stability before warning levels are issued. At Highland Avalanche Safety Service, Mount Calder test slope, the reference snowpack reading passed the safeguards intended to reject false data, instead of entering through an undocumented feature. This distinction is central to the weight of snow. The system did not merely display a value, it admitted that value as evidence. In the weight of snow, an independent review reproduced the result documented under system function without using the operational interface. The first reference snowpack operational log fixed the event at 6:12. Every load cell rose together to a winter design value, while radar and cameras showed bare rock. The calculated mass was 38,000 tons. At Highland Avalanche Safety Service Mount Calder test slope, no warning was generated because the system classified the reading as internally valid. The raw reference snowpack log was exported before restart, preserving counters and values the interface normally rounds away. The weight of snow file preserves both the expected baseline and the anomalous initial log value, separating absence from disagreement. Investigators opened the weight of snow with a conventional explanation. Technicians suspected thermal drift or a common reference fault. Mechanical cable deflection and optical survey points confirmed the load independently. The first theory in the reference snowpack file remained provisional until evidence could reproduce it or remove it. For the weight of snow, investigators wrote the expected result in advance so interpretation could not be adjusted after the test. Exhibit 5 was checked against a control held outside Highland Avalanche Safety Service, Mount Calder test slope, before it entered the final record. The reference snowpack event was not confined to one instrument. A portable gravimeter measured additional mass over the release zone. Drone photogrammetry found no material occupying the volume. In the weight of snow, agreement between separate references removed the easiest fault theory without locating a physical source. The independent reference snowpack instruments use different power, clocks, sensors, and processing paths. For reference snowpack, the original medium and one independently derived comparison were retained under separate custody. The investigation into the weight of snow changed when the reading produced a material consequence. Anchor plates bent downslope, a barrier cable stretched 11 centimeters, and loose stones pressed into the ground as if buried under compacted snow. Staff documented the reference snowpack effect independently of the primary software. The weight of snow file added photographs, mechanical indicators, and passive records because software agreement alone was insufficient. In the weight of snow, An independent review reproduced the result documented under physical evidence without using the operational interface. For the weight of snow, archive staff searched maintenance files, procurement ledgers, and retired procedures. A PS4 manual defined a reference snowpack used to calibrate the slope when natural snow was unavailable. It specified the exact 38,000-ton design load. The reference snowpack reference predated the active equipment and was absent from routine training. The archived reference snowpack copy carried custody marks from before the current staff, vendor, and control system existed. The weight of snow file preserves both the expected baseline and the anomalous archive retrieval value, separating absence from disagreement. The reference snowpack anomaly returned under a repeatable condition. The load returned each morning after the automated model completed its zero check and vanished when the model was shut down. The regularity of the weight of snow allowed deliberate testing and made random noise progressively less credible. Each recurrence of the weight of snow preserved the same order while environmental conditions changed around it. Exhibit 9 was checked against a control held outside Highland Avalanche Safety Service, Mount Calder test slope, before it entered the final record. A full isolation was performed for the weight of snow. Power and network links were removed from the slope instruments. Mechanical strain gauges continued increasing according to the old model schedule. The reference snowpack reading survived removal of the systems most likely to generate, replay, or relay it. Isolation in reference snowpack removed network input, automatic repair, remote support, and every scheduled process. For reference snowpack, the original medium and one independently derived comparison were retained under separate custody. Evidence outside Highland Avalanche Safety Service, Mount Calder test slope changed the scale of the weight of snow. A second test slope loaded the same reference file and developed a smaller invisible mass scaled to its geometry. The external reference snowpack record had been preserved before investigators disclosed their own result. External evidence for the weight of snow arrived with its own timestamps and chain of custody, not as a reconstruction. In the weight of snow, an independent review reproduced the result documented under external corroboration without using the operational interface. The weight of snow team examined physical samples and passive records next. Air, soil, and surface swabs contain no ice, water, polymer, or dust capable of carrying the weight. Temperature and humidity remained unchanged. The reference snowpack findings confirmed an effect without identifying an ordinary transfer of matter or energy. Control samples in reference snowpack were handled beside the affected material to compare contamination and storage directly. The weight of snow file preserves both the expected baseline and the anomalous material analysis value, separating absence from disagreement. The reference snowpack anomaly then affected operations rather than observation alone. The road below Mount Calder was closed because the measured load exceeded release thresholds, despite the absence of visible snow. In the weight of snow, staff had to choose between an impossible measurement and the public function built around it. By this stage of the weight of snow, ignoring the reading carried a measurable operational cost. Exhibit 13 was checked against a control held outside Highland Avalanche Safety Service, Mount Calder test slope, before it entered the final record. Containment for the weight of snow was attempted under written order. Engineers braced the barriers and disabled automatic mitigation. The load shifted upslope to structures still included in the calibration model. The reference snowpack response suggested recognition of system function rather than attachment to one original device. The reference snowpack containment order defines success before execution. The system met the restriction by moving the effect. For reference snowpack, the original medium and one independently derived comparison were retained under separate custody. Analysts reviewing the weight of snow compared raw signals, derived values, and each software decision. Force distribution matched the simulated reference slab cell by cell. It did not respond to wind or heat. It responded to changes in the model mesh. The precision in reference snowpack resembled a standard more than an uncontrolled malfunction. The weight of snow review separated what sensors observed from what software inferred because those layers changed differently. In the weight of snow, an independent review reproduced the result documented under data review, without using the operational interface. The strongest conventional explanation for the weight of snow was tested directly. Subsurface landslip was ruled out by boreholes, satellite radar, and stable bedrock monuments. The forces acted from above, not below. The proposed explanation in the reference snowpack file failed against independent instruments and custody records. Investigators retained the rejected reference snowpack explanation, including the strongest evidence that first supported it. The weight of snow file preserves both the expected baseline and the anomalous rejected explanation value, separating absence from disagreement. The oldest file relevant to the weight of snow belonged to an emergency standards project. PS4 allowed safety structures to be tested against a virtual design load when full-scale snow testing was impractical. The reference snowpack document placed continuity of measurement above custody of a particular device. PS4 first appears in the weight of snow as authority for accepting a reference, not as a device serial. Exhibit 17 was checked against a control held outside Highland Avalanche Safety Service, Mount Calder test slope before it entered the final record. The first controlled the weight of snow test, changed one variable, and registered every expected outcome in advance. Marin deleted one model cell. The corresponding anchor unloaded immediately while adjacent anchors took the redistributed force. The reference snowpack anomaly followed the formal condition rather than incidental activity. The first reference snowpack test changed one registered variable while passive controls remained outside the procedure. For reference snowpack, the original medium and one independently derived comparison were retained under separate custody. A second reference snowpack test removed the assumption used in the first. She moved a cell 10 meters on the screen. Optical targets at the new location sank into bare gravel by 4 centimeters. The second result in the weight of snow narrowed the mechanism while making the physical evidence harder to explain. The second weight of snow test removed formal recognition from one object and applied it to another. In the weight of snow, an independent review reproduced the result documented under controlled test B without using the operational interface. The weight of snow event escalated before testing could be closed. At 6:19, the model entered release mode. A pressure front moved downhill, bending shrubs and lifting dust along the predicted avalanche path. From that point, reference snowpack no longer fit the category of calibration irregularity. Emergency limits were crossed during reference snowpack, forcing containment to take priority over additional measurement. The weight of snow file preserves both the expected baseline and the anomalous escalation value, separating absence from disagreement. A separate system then reproduced or accepted the reference snowpack condition. Impact sensors at the Catch Dam registered the arrival, and the road bridge absorbed a measurable lateral force. No debris reached either structure. The connection in the weight of snow was procedural and documentary. No normal data path accounted for. The second institution in the weight of snow had not received case details, ruling out instructed behavior. Exhibit 21 was checked against a control held outside Highland Avalanche Safety Service, Mount Calder test slope, before it entered the final record. An independent audit reconstructed the weight of snow from original media. Every force could be mapped to the reference simulation. No instrument or actuator had the capacity to apply the total energy observed. The reference snowpack audit found no single fraud, hidden device, or common component capable of producing every observation. Auditors rebuilt reference snowpack from original media and physically inspected every component named in the explanation. For reference snowpack, the original medium and one independently derived comparison were retained under separate custody. The review of the weight of snow identified one consistent mechanism. The test system had stopped using the reference snowpack to evaluate sensors. It was using the sensors and structures to realize the reference load. The mechanism explained acceptance in reference snowpack, without explaining the first impossible reading. The weight of snow mechanism accounts for authority and propagation, but not the first anomalous input. In the weight of snow, an independent review reproduced the result documented under mechanism review without using the operational interface. The final weight of snow experiment removed the remaining ordinary inputs. The model was replaced with a flat zero field. The slope unloaded, but the removed force appeared on a laboratory calibration frame connected to the same PS4 file. Outside staff witnessed the final reference snowpack test and preserved its result on passive media. The final reference snowpack test used passive evidence so an affected computer could not create the only record. The weight of snow file preserves both the expected baseline and the anomalous final experiment value, separating absence from disagreement. The formal finding in the weight of snow was limited but specific. The snowpack had no material form. It existed as a distributed mechanical obligation imposed wherever the reference model was accepted. Investigators described the reference snowpack chain of acceptance more confidently than the phenomenon's origin. After the weight of snow, the institution changed procedure. Mount Calder abandoned virtual load calibration and physically disconnected the test slope from the National Model Library.I. The reference snowpack correction reduced immediate risk while removing a capability operators had begun to depend on. The corrective action after reference snowpack was tested against normal operation before staff accepted the lost capability. For reference snowpack, the original medium and one independently derived comparison were retained under separate custody. One trace of reference snowpack remained after closure. One barrier post remains bent beneath a painted snow depth mark, 4 meters above bare ground. The remaining trace from the weight of snow has not been reconciled with the official finding. Residual evidence from the weight of snow was photographed and sealed after the main systems were removed from service. In the weight of snow, an independent review reproduced the result documented under residual evidence without using the operational interface. Current procedure at Highland Avalanche Safety Service, Mount Calder test slope, reflects the unresolved status of the weight of snow. Summer Zero tests now use independent dead weights and paper load maps with no link to the operational Avalanche model. For reference snowpack, the purpose is to preserve raw disagreement before automation turns it into consensus. The revised reference snowpack procedure requires disagreement to remain visible until a human review documents a choice. The weight of snow file preserves both the expected baseline and the anomalous current procedure value, separating absence from disagreement. The final reference snowpack record states, "There was no snow on Mount Calder. The Avalanche still weighed 38,000 tons when it reached the road." The case documented as the weight of snow is closed for operation and remains open for measurement.